Mia Kynadi, who is a director and CEO of Beyond Is LLC. She is a seasoned data scientist and entrepreneur. She is also part of Venture Way, which is the investment firm. With her background from Qualcomm and education from MIT and Stanford and Harvard, Mia is an active angel investor as well. As a founder and managing trustee of Chaya Foundation, she supports unprivileged education, children's education in India and is establishing a foundation for AI to empower marginalized women and students in the AI workforce. Thank you, and I would like to welcome her. Thank you.
Thank you. Thank you so much, everyone. It's a pleasure to be here. So welcome to the session, Gen AI, the opportunities amidst the noise. In the session today, I'll go through just a brief introduction of what generative AI is. We'll go into a timeline of a few of the interesting milestones in the journey that brought us to today. We'll go through some industry applications and use cases, some insights, and then we'll wrap up with the question and answers. So what is generative AI? So it is just a class of algorithms that generates new content in response to some input, some prompt, right? So it is trained on existing data, but it generates new content. And I'm sure all of us have, interacted with ChatGPT. And when you give it a prompt, it really feels like GPT is understanding and reasoning over your content. But what is it actually doing under the hood, right? So when you give a prompt to ChatGPT, it is really only calculating what is the most likely next word that it should put out. So given that this is your prompt, what is the most likely first word of the answer? That's all it's looking at. And then once it puts that first word out, it's looking at, given the prompt and given that the first word of the answer was, let's say, A, what is the most likely next word? So it is really just reasoning and predicting the most likely word at every time step. To be very accurate, it's not predicting words, it's actually predicting tokens, which would be like pieces of words. So although in a large sense it feels like it's really reasoning and understanding, under the hood it is just predicting tokens one step at a time. So what makes generative AI possible today? It's a confluence of two things. It's big compute and it's big data that have come together at the right time. So in terms of compute, these large models that we deal with today, large language models, large vision models, they all need a lot of compute, and that has become available today. And in terms of data, there are a lot of things that contributed to having a lot of data available. Internet connectivity, there was 5 billion internet users, 4.95 billion on social apps. And so that's a lot of content right there. Cloud computing is another big enabling factor that has brought a lot of apps into the market, because you don't have to have all your infrastructure and all your data with you physically. You can use Amazon Web Services or Microsoft Azure. They have GPUs, they have storage for your data. So you can actually train these really big models on the cloud without really having that infrastructure with you. So that has enabled a lot of apps to come into the fore. Smartphone penetration. Again, everybody has so much data and it's just getting uploaded all the time. So a lot of data there. And profusion of content. This is from a year ago, but you can say it's 41 million WhatsApp messages traded every minute worldwide. That's the kind of data that people are generating. So in terms of generative AI, the structured tasks where you have an input, you know clearly what needs to be done on the input, and you have outputs. And that was something computers were very good at doing. And you have unstructured tasks where the inputs are not well defined, it's not a clear transformation, the outputs are not well defined. And those unstructured tasks were often human only activity, like creating music, creating art, creative writing. But those are the things that now generative AI is able to do. So it's really pushing the boundaries of what was considered human only activities some time ago. Okay, so this is So before I get into this, I just want to talk about what foundational models are. You would have heard that term mostly. These are large models which have been trained already, and they are good at some tasks, and you are able to use it as a consumer without having to train it or anything. You're able to interact with it. So GPT is a foundational model. Latent diffusion foundational models are there. So there are a lot of companies who have foundational models and which we can use as consumers in with generative AI. The simplest level I would say is as a consumer app like ChatGPT, for instance. You are just putting your prompt into the interface and you get your response back. So you don't really need to know anything about what's happening under the hood. So that is really I think the simplest way of interaction with generative apps. Um, the next is you could make a custom interface, for example. Like if you wanted a chatbot that is specific to your company, you could build just a chat interface, but under the hood, you're just calling the API of GPT-4 from OpenAI or another API, for instance. So you're not really training a model, but you are interacting with a model, but your user interface is custom made. So that's another level, another trim level. Prompt engineering with context is where you go a little deeper. In your prompts, you can actually include context that will help the model to reason and give a better answer. So again, you're not training a model, you're not really getting into the knobs and whistles of the model, but you're doing some prompt engineering, you're adding some context into your prompt, and you're getting a better response. And the next level is to fine tune models. So fine tuning is where you're not training the whole big model. Models are now run into, Chat GPT. Sorry, GPT-4 is rumored to have upwards of 1.7 trillion parameters. So if you want to train that model, the kind of memory and hardware that you need is pretty considerable. But you're not going to train that whole model, but you train a small layer of that model on your data so that it performs better on the task that you want it to perform. So that is fine tuning. So that's the next level. And then the foundational models, what I mean there is you're going to just build a model yourself from scratch. But I wouldn't recommend that for most use cases because it is expensive. It takes a lot of compute. It takes a lot of time. It also takes a lot of expertise. So we'll get into some of these. Okay, so I want to get into just a brief timeline of some of the interesting things that happened along the way. So, what I mentioned about foundational models, I'm going to be mentioning some of the interesting foundational models that have come out over time, right? And our story actually starts way back in 1966. This actually, Eliza, is the first artificial intelligence chatbot. Way back in 1966, it was at MIT, Dr. Weizenbaum. But Eliza doesn't have any of the capabilities that we know of ChatGPT and things like that today. It was just really a pattern matching engine in some ways, and it would just paraphrase what the user was saying in other ways. Um, but the funny thing is, it gave rise to something that they started calling the Eliza effect. So, although Eliza was not reasoning, not understanding, it was just really a very simple chatbot, but people started attributing human qualities to it. People said, oh, it's empathetic, it's understanding, it is humorous, whatever, right? So, that is called the Eliza effect. In fact, just a few days ago, I was passing by my husband's office, and he was being profusely apologetic and profusely thankful to somebody. So I stepped in to find out who it was, and it turned out he was talking to ChatGPT. So that is Eliza effect right there. So, okay, so a lot of things happened after 1966, which I didn't get into. 2017, researchers at Google put a paper called Attention is All You Need. And in that paper, they released this architecture. It's called a transformer. When you talk about GPT, G is generative, pre-trained transformer. And so this is the original transformer architecture from that paper. I just wanted to put it out here because transformers have underpinned a lot of the other models that have come after. It has enabled a lot of the progresses in generative AI. We do have time for questions at the end. So if anybody has questions about that, I can get into it there. 2018, OpenAI released GPT-1. It had over 100 million parameters. 2019, OpenAI released GPT-2. It had 1.5 billion parameters. 2020, GPT-3 came out with 175 billion parameters. At the same time, Google released their language model, Lambda, which is also transformer-based, but they didn't make it available to the public. In 2022, Google also released Palm 2, and their Google Bard was originally based on Lambda and then on Palm 2. Latent diffusion models actually are foundation models that underpin a lot of the image generation apps we've seen, like Stable Diffusion, DALL-E, and Midjourney. In 2022, OpenAI released ChatGPT, a date that nobody can forget, and that was originally based on GPT-3. And ChatGPT is the largest growing consumer software application in history. It's reached 100 million users by Jan 2023. So that's how fast it caught fire. And Feb 2023, Microsoft released Cosmos. Cosmos is a foundational model that is multimodal. And what that means is that you can interact in more ways, in more modes than one. So not just text, it could be text and image, it could be text and image and audio. So multiple modes of input, multiple modes of output. Microsoft Cosmos was one of the earlier models that did that. Meta released a language model called Llama, also in 2023 Feb. In March 2023, OpenAI released GPT-4, and then ChatGPT was also running on GPT-4. Khan Academy is an ed tech company. I don't know if you've heard. They released a tutor called Khan Migo. So they were given early access to GPT-4, and they developed Khan Migo along in conjunction with OpenAI. I'll talk more about that later. And in July 2023, Meta released Llama 2. Llama 2 is maybe the first model that was completely open sourced with also a commercial license. So you were free to also build commercial apps on Llama 2. And in December 2023, now Gemini just came out from Google, which is multimodal from the ground up. Very interesting, actually. And Gemini, they've released in multiple sizes. One of them is a 1.3 billion parameter size for your devices. You can run it on your end devices. And they use something called weights distillation, where they've transferred knowledge from their big Gemini model into this little guy so that he also has state-of-the-art performance. Okay, so I'm going to go into some industry applications and use cases. Knowledge-based management. So this is for any company that has a lot of data that is spread over multiple formats, multiple locations. So whenever you have a lot of data that you need to check to get the information you need to do your work, it's great to have a generative AI application running on top of it. The Gen AI can reason over your data, can give you summaries of your data. It's a very good solution to have. Interesting case studies. One is Bloomberg. So Bloomberg actually built a model from the ground up called Bloomberg GPT. They used 40 years worth of financial data. So not everybody can afford to do a Bloomberg. But Morgan Stanley worked with OpenAI and built this retrieval augmented generation system based on GPT-4. So this is what it is, right? So normally we have a prompt, we give it to our large language model and you get an answer. But when you do retrieval augmented generation, you're also retrieving relevant documents from your knowledge base, stitching that together with the prompt and giving that to the LLM. So then the LLM is reasoning over the relevant documents and giving you a well-grounded answer. Another problem that language models do have is hallucination. Like GPT will tell you things that are not true, and unless you really fact check, you can get in trouble. But with this kind of a system, you can really ground your language model so that its responses are grounded in fact. Marketing and advertising. Just because there's so much of content to be generated, there's so much of design to be done. Um, Generative AI can really help in content creation. It can help in building a brand voice. If you have a lot of content already out there, you can actually, there are tools that will generate new content in that voice. You can make sure that there are keywords that are included so that your search engine optimization and all the things that are taken care of. You can have, for customer outreach, you can really use these models to give you customer insights, hyper personalized content. um, so you have some of the tools that you can use. This, I'm sorry, is not clear. This is Stable Diffusion and Mid Journey, which you can use for image generation. You can really run through a lot of logo designs, image creation. You can experiment very quickly and very cheaply with these tools. These are specifically trained for marketing and blogs and all of those. In healthcare, so one of the big things in healthcare is that there's a lot of documentation that needs to be done. By some estimates, almost over 20% of a doctor's time is in documentation. And that actually contributes to burnout in a big way. So there are a lot of tools that help in documentation. That's one. In mental health, I think even Satya Nadella spoke about how he sees AI being a big solution in the mental health space, because a lot of people don't have access to mental health care, and there's a stigma around actually going and seeing someone. So in healthcare, there are tools that exist for documentation. Abridge and DAX Copilot are tools for documentation in healthcare. Glass Health is a tool that actually helps in differential diagnosis. So if you put in all the symptoms, it suggests what things the doctor can consider, what may be the clinical trial options, I mean treatment options. Also, Palm, Google has trained its Palm model on medical data specifically, and have a model called MedPalm 2. It was the first one that reached human performance on some medical exams, actually. EdTech, again, there's a lot of startups in the EdTech space. There's a need for tutors. There's need for customized study plans. There's need for practice questions. There's need for someone to really sit with the student and help them work things through. Khan Migo that I mentioned earlier is one of those. So, I mean, if you ask ChatGPT a question, it will give you the answer, and often it could be the wrong answer. But Khan Migo doesn't do that. So they've trained it so that it helps the student work through and think through questions. And an interesting thing is it allows students to chat with AI-powered historical figures, so that it really internalizes their memory in history and things like that. So it's a very interesting tool. Legal services, again, is one of those areas where you have so much data to process, case studies to consider, compliance to consider. So legal services is another area where generative AI has some very interesting solutions. Must be vetted by a lawyer. So there was a case in June 2023 where a judge actually punished a couple of lawyers because they got their case written by ChatGPT, and it actually quoted things that never happened. It actually quoted cases that never happened. So a word of caution is always there. Yeah, so Allen and Overy is a legal firm that partnered with an AI firm called Harvey. I don't know how many of you watch Suits. And Harvey is this top shot lawyer who knows everything and remembers everything and is the coolest. So Harvey AI is interestingly backed by a fund, an OpenAI fund, and it's based on GPT-4. So it pulls up relevant cases. It gives summaries. It gives compliance suggestions and things like that. So Harvey is an interesting tool again. And like that, there are many industries that have use cases. Finance is one. You can drive customer interactions. You can drive product recommendations. In fact, Kerala, there's a startup called FinGPT that pitched to us a few days ago, where if you upload big documents, it actually summarizes and helps you make sense of it using a generative AI solution. In business and strategy, you can go through idea generation much faster. You can bounce off ideas with the generative AI tool. You can communicate strategies much better. In coding, there are a lot of coding tools that increase productivity, almost 55%. Actually, GitHub Copilot and ChatGPT Code Interpreter are some of the tools that are out there. There are many that are out there, actually. Data center management is a new thing that's coming up because of the compute requirements of AI. Data centers are adding more capabilities, they're upscaling. But what goes along with that is they need power and they need cooling, and it's better if it is real time monitored rather than powering everything and cooling everything all the time. If you can actually monitor and cool it on demand, so that's something that actually we've been exploring also. So what are some of the insights for leadership? What are the ways in which your business can leverage AI? What are some of the things to think about? So one thing is to have the time is now to actually have AI to AI enable your business. But things to think about is what are your pain points? What are some specific goals that you can achieve in your company? And some of the things that you should do is one is data readiness. Whatever sort of AI solution you want to have, you're going to need data for it. And data needs to be good quality, it needs to be error free. So, those are things, frameworks that you can put in place. Understanding what good quality data is, how to collect error free data, how to organize it, and upskilling your workforce. At the very least, having everybody just understand how prompt engineering works, because the quality of outputs that you get from any sort of generative AI model will depend on the quality of your prompts. So it's a good few hours spent to understand what good prompt engineering is. And then familiarity with productivity tools, understanding of how to collect good data. So even something as simple as converting text fields to drop downs so that it really limits the scope for error. Simple things can go a long way. But also understanding what are the limitations of AI, when should you not use it, how to attribute generated content, that's content generated by AI. These are all things that you can help your workforce to understand. What are some of the limitations and ethical concerns? So AI generated content often cannot be copyrighted. So I think the laws are still moving in motion on that. So, but that's good for you to know. Generative AI models still hallucinate and can get facts wrong. If you're using public APIs, for example, if you're just using ChatGPT to run productivity in your company, whatever you send in the prompt can be used by that company to train future models. So the privacy of your data is something that you need to look out for. And if that is a concern, then you want to consider being behind a firewall or something like that. It's a fast changing field. There are new models and approaches coming all the time. But still, it's a good time to focus on data readiness, focus on your workforce readiness. And also, in a completely deployed AI system, the AI model will be a small part of it. You can get the entire framework, everything ready, and roll out. And if you have to change your model at a later stage, but you will still be an AI enabled and AI ready company. And I think the time is now to make those considerations. Ethical implications, there are algorithmic biases, can be, it's a lot better now. I mean, there can be racial biases, gender biases. A lot of these models now, for example, even ChatGPT goes through a moderation endpoint, which is another model that looks at the output of ChatGPT and makes sure that it's not, discriminating in any way. It may provide harmful content, it may provide inappropriate content. So whenever you thinking of rolling out a system in your company, you want to also have a sort of an audit that goes on before it goes live. And there are many ways to deploy. For example, you can do a partial deployment so that you can monitor your AI outputs over time and see if it's ready to go, and then slowly ramp it up and get to full deployment. Looking into the immediate future, these are things that are already happening. Better prompting techniques like chain of thought and tree of thought. Chain of thought prompting is a very interesting thing where if you tell the model to reason step by step, you just ask the question and say reason step by step, you find that it can answer a question that it couldn't otherwise answer. Customized generative AI solutions using retrieval augmented generation. So a lot of companies are already using this because it allows you to build solutions on top of your data without having that additional load of training a model. So that's a very it's a good approach, and it's becoming easier to fine tune foundation models in the sense that you have cloud computing. A lot of foundation models are open source. And there are a lot of newer tools and infrastructure companies that are coming up. There's also generative AI with the ability to call external APIs. Like you can have your generative AI run a search, I mean, reason about your question. If it needs additional information, run a search, get that answer, reason over that, and then give you the answer. So, you're able to call external APIs from within your generative AI solutions. So that's another thing. The pursuit of artificial general intelligence, that has been the thing for the AI industry at large. They want a general intelligence, like not models that reason in silos that are good at some tasks but not at others, but a general intelligence. So that is the golden pursuit. This is just some of the many apps, consumer apps that are out there. This is not very clear, I think, but for sales, for healthcare, in the legal space, search and knowledge, there's so many. So whatever your use case is, there's a good chance that there's a good app out there already. And if not, there are many ways, many levels at which you can consider building solutions. That's it. Many questions? I feel like it's a new paradigm altogether because also it's multimodal from the ground up. So GPT, most people think, because the technical report doesn't give any details, but they feel GPT under the hood is multiple models, right? So it's like if it's audio, then it's a different GPT that's reasoning over the audio, and then it's like a mixture of experts ensemble. But Gemini is all the modalities, which is video, audio, text, and image. They are all brought into the same embedding space, and the model is reasoning over that entire content. So I feel like it's a more powerful model. I think it will drive apps that we haven't seen yet. It's I think the next big thing.
You would have seen, ever since creating apps on top of GPT has become so easy, just add another layer with a prompt, then it's a whole new use case. You would have seen a lot of apps like this coming in maybe hackathons or something towards you. So, is there any certain use case where you felt like, oh my God, this just revolutionized the current sector, or this is about to take it one step higher? Is there any certain such use case that you've seen?
I think for me, that was the knowledge management use case with the retrieval augmented generation, because that's just useful for across industries. It grounds the model, and it allows you to update your data on the fly. Like if you had to train a model on your data, and then when your data changes, you're going to have to retrain your model, which is time consuming and expensive. But I feel like retrieval augmented generation is just so smart and helps you get running very quickly.
Explain about retrieval. So how can some organization do it practically? Is there any tool available?
There are several. So what you need is, one is you have your database, and you need to make it a vector store. So what you do is, you're converting it into some sort of a vectors, so that when your query comes, you want to be able to quickly search and find what are the closest documents to that query. So one is storing your information in a vector database, and the second is searching over that vector database and retrieving. So search and retrieval. So you need something to store your data in, you need something to search and retrieve it, and then you just need your prompt engineering where you have your query, you're stitching on your whatever content you retrieved, You send it to the language model, and it gives you the response. So in simple terms, that's all. Yeah, LLM. So in LLM models, if you're talking about how the text gets eventually represented, it is as vectors. Everything gets into vectors. That's what is called an embedding. So everything gets converted into an embedding, which is just a vector of numbers. And the in the retrieval augmented generation, um, also we're talking about embeddings where the documents are converted into some sort of embedding that has a semantic relation to what that document is talking about. So that when you get your query also gets converted into an embedding, and then you can compare distances between embeddings. So that tells you which documents are close to your query.
How is it different from fine tuning? Like if we have the RAG, right? So how is it different from fine tuning? So what advantage we have with
So
fine
in
tuning?
fine tuning, you are changing some of the parameters of the model, right? Like how does a model learn? By adjusting its weights, right? When you're training the model, it's you're giving your training data. The model makes some output initially, and depending on how far away the model's output is from the training output, it adjusts its weights so that the next time.
That cosine similarity, but that's happening with RAG also, right? So how,
Yeah, no, the in fine tuning, but you are changing your model. The parameters
foundation
of,
model itself.
yeah,
Okay.
some of the layers of the models is getting changed. You are training the model by changing the model. In RAG, you're not changing the model at all. You are just giving the model additional context along with the prompt.
Okay. Yeah. Yeah.
Understood.
Makes
So
sense.
which is why it's so much easier to get up and running with RAG.
Yeah. RAG is easy.
Yeah.
Thank you.
Limiting the capabilities by focusing on a certain context.
So, I mean, one way you could think of it as limiting the capabilities, but the other way you can look at it uh, is the time and what is the time and cost of fine tuning the model, and what is the performance gain you get for your use case by fine tuning? Is it worth it? That's the question yet you have to ask, and it's always not the same answer. In some cases, maybe it's better to fine tune, but in some cases, perhaps not.
For talking about AI, generative AI, and thank you for showing us there is more to than what we see in terms of ChatGPT.